Hello, my dear students. Today we will discuss the nature of roots of quadratic equations. Notice that when you are solving for the roots of a quadratic equation using quadratic formula, the number inside the radical sign, which is represented by b squared minus 4ac, sometimes results to 0. Sometimes it results to a positive number or greater than 0, and at the same time it's a perfect square. PS. Sometimes it's also greater than 0, but it's not a perfect square. Not a perfect square. Sometimes it's less than 0 or negative. So this b squared minus 4ac here describes what kind of roots does our quadratic equation have. So without actually solving for the roots of a quadratic equation, you can identify the nature of roots of a quadratic equation by just using this b squared minus 4ac. So it is called the discriminant. b squared minus 4ac is called the discriminant. And here are the nature of roots of our quadratic equation based on the result of our discriminant b squared minus 4ac. Kung ang b squared minus 4ac na nasolve mo ay equal sa 0, then ang nature ng roots na masosolve sa quadratic equation ay rational and equal. If our b squared minus 4ac naman ay greater than 0, and at the same time, it's a perfect square, then yung roots ng quadratic equation mo ay rational but not equal. And if ang b squared minus 4ac ay greater than 0 pero hindi siya perfect square, not perfect square, then it's irrational and not equal. And lastly, if b squared minus 4ac is less than 0, meaning negative yung discriminant, then the roots of that quadratic equation is imaginary or not real. Okay, let's consider some examples here. Determine the nature of roots of x squared minus 12x plus 36 equals 0. Okay, first I will show you the roots of this quadratic equation using quadratic formula here. So, x equals negative b plus minus the square root of b squared minus 4ac all over 2a. By substitution, our b from our original quadratic equation is negative 12. Substitute it here, negative 12. Plus or minus the square root of b squared. Again, use b negative 12 minus 4 being the constant. A, which is understood 1 ang A natin. And C, which is 36. So, ito. All over 2A. So, 2 times 1. Simplifying further, we have x equals 12 plus or minus 144 because 12 is squared or negative 12 is squared is 144 minus 144 all over 2. And simplifying the number or the operation inside the radical, that's 144 minus 144 equals 0 here, 0. So 12 plus or minus the square root of 0 all over 2. And by eliminating 0 because it's no longer significant, 12 divided by 2, which is equal to 6. Notice that we only have one root. But for all quadratic equations, there are always two roots. So our expression for the solution will be the roots are 6 and 6. So they are equal. Now, we will show you the nature of roots here using our discriminant. So by discriminant b squared minus 4ac, substitution negative 12 quantity squared for ac, so 4 times 1 times 36 is equal to 144 minus 144, of course 0. So as you can see, our discriminant is 0. Based on the descriptions of b squared minus 4ac, when it is equal to 0, then the roots are real and equal. And obviously, 6 is equal to 6. They are equal. Okay, let's consider another example showing another case. Determine the nature of roots of 3x squared minus 14x plus 8 equals 0. So first, we have to identify a, in this case, 3, b, which is negative 14, and c, which is 8. Next, after identifying a, b, and c, we are now ready to substitute them into our discriminant b squared minus 4ac. And so, by substitution, that's negative 14 quantity squared minus 4ac. In this case, 3 ang a natin at ang c natin ay 8. And simplifying further, we have 196 ang negative 14 squared. And 4 times 3 times 8 is 96. Then 196 minus 96 is of course 100, which is a perfect square because if we extract its square root, then it's 10. The square root of 100 is 10. Now, since b squared minus 4ac is greater than 0 and a perfect square, then the roots are rational but not equal. Rational but not equal. And by the way, rational kasi pwedeng express sila sa fraction, but they are not equal. So, it's your activity to identify the roots of this quadratic equation. And you will find out that the roots are 2/3 and 4. Now let's consider another case in our next example. Determine the nature of roots of 2x squared minus 4x plus 1 equals 0. First, we have to identify a, b, and c. Our a in this example is 2 and b is negative 4 while c is 1. So after identifying a, b, and c, we are now ready to substitute them into our discriminant b squared minus 4ac. So doing the substitution, we have negative 4 quantity squared because our b here is negative 4 from here minus 4 times 2 because our a here is 2 and c is 1 from here. So 4 or negative 4 quantity squared is 16 minus 4 times 2 times 1 is 8. Doing the subtraction, we have 16 minus 8, which is 8, which is of course not a perfect square, but of course it's greater than 0. Since b squared minus 4ac is greater than 0 and not a perfect square, then the roots are irrational and not equal. Irrational in a sense that they can no longer be simplified or they can no longer be taken out of the radical. And if you do some computation using quadratic formula, you will find out that the roots are here. 2 plus square root of 2 and all over 2 and 2 minus square root of 2 all over 2. So this square root of 2 here can no longer be simplified. Okay, in this example, I will show you the last case in describing the nature of roots of a quadratic equation. Describe the roots of 3x squared plus 9x plus 11 equals 0. Again, let's identify our a. So in this case, it's 3 and b, 9, while our c is 11. After identifying our a, b, and c, we are now ready to substitute them again into our discriminant b squared minus 4ac. So in this case, our b is 9, so 9 is squared minus 4 here, 4 times 3 times 11. But 9 squared is 81 and 4 times 3 times 11 is 132. And 81 minus 132 is negative 51, which is obviously it's less than 0. So therefore, since our b squared minus 4ac is negative and in symbol it's less than 0, then the roots are imaginary. They are imaginary because the radicand or the number inside the radical could no longer be simplified and it is not really existing. So if you try to do some computations using quadratic formula, you will find out that the roots are negative 9 plus square root of negative 51 all over 6 and negative 9 minus square root of negative 51 all over 6. And using the symbol I, it's negative 9 plus I square root of 51 all over 6 and negative 9 minus I square root of 51 all over 6.